Hello, students. This is a review for your test coming up on Thursday for those in 4th, 5th, and 6th block. For those in 3rd, you will have your test on Friday. And so this is very similar to your review. This is what I've given. This is just a little bit of extra help in what I'm trying to do. All right. If you notice right here, okay, they're asking us to solve for x. So I know that this whole thing, okay, equals x plus 20. Okay, and so since I know this is 13 going from T to R, this is A going from S to Q, okay, I know, okay, that this part right here, okay, is going to be 5, all right, or we could do it this way. I think this way is a little bit better. Since I know that this whole thing is 13, okay, and this is x plus 13, we know that TS is x, okay? So I know that this part is x. This part right here, if I take away 8, because I know that that's what this whole thing is, okay? If I take away 8, then I know that this is going to be x plus 5. And so I can add all those up, set it equal to x plus 20, and you should be able to find your value of x. Okay, find the midpoint. Okay, so when I'm finding the midpoint, I use the midpoint formula. Okay, make sure that you pay attention when you have just endpoints and when you have an endpoint and a midpoint. You still use the same equation. It's just with this one, okay, you're just going to do x2 plus x1 over 2, comma, y2 plus y1 over 2. Then on the given endpoint and midpoint, okay, given the endpoint and midpoint, all right, this is where you're still going to use same equation, except this time you know your midpoint. You don't know the x2 and y2 sitting out here. So you're going to use x2 minus 9 over 2 equals negative 6. Then you're going to have y2 plus 3 divided by 2 equals negative 6. All right, find the distance. Use your distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and so this one, you're just finding your x and y values right here, okay, and plugging them in and finding what the distance is. All right, now, taking a little bit of a different trek with your with finding the missing side of a right triangle. We're still going to use Pythagoras, x squared or a squared plus b squared equals c squared. Okay, so we're going to have x squared, a squared, which is 7 squared, plus b squared equals square root of 197 squared. Now remember, whenever I take a number, it's in the square root. So if I take the square root of 21 times the square root of 21, I get 21. So in this case, I get the square root of 197 squared, okay? And so that's going to give me 197. So I'm going to take 49 plus, oh gracious, b squared, equals 197. And so I take 197 minus 49, take the square root of that. Okay? All right. Now, you are going to see this on the test tomorrow, or on the test this week. You have in number 6, you have the cosine. Okay? Remember, cosine, caught another hippie. Cosine equals adjacent over hypotenuse. Okay? So cosine of C, all right, is going to be the adjacent side here of 27 over the hypotenuse of 45. Sine, some old hippie, okay, S over O, opposite over hypotenuse. Okay, so sine of x, opposite 40, opposite 40. Okay, hypotenuse 50. All right, and then tangent, tripping on acid. T, tangent. O, opposite, over adjacent. Okay, so tangent of A, opposite 6 over 8, of course, which is going to reduce. All right, then find the slope of each line. This one, okay, real quick, negative A over B. A is 5, B is negative 3. So minus 5 over negative 3 minus 5 over 3. All right. Then, okay, find the slope of the line parallel. This means that the slopes are the same. In parallel lines, slopes are the same. So I have negative A, so 2 over negative 1 minus 2 over negative 1. I have two negatives, so it's going to change to a positive. So my slope is 2. All right. Now on this one's a little easy. Okay. All right. Now again, these are going to be very similar to your test. All I'm going to do is click the little arrow that lets them regenerate. And so this, again, some of these I may even keep. I don't know yet. Okay. But you have A of 1, B of 1. So you have negative 1 over 1. Okay. So your slope of this line is negative 1. Okay. Now, if I was looking for a line, okay, if my slope is, here, let me get my hands right. Okay, so if I have a negative 1, okay, trying to do it to where, there we go. Okay, so I've got a negative slope. I have a line coming in that is perpendicular, so it forms a 90-degree angle. So it's going to be the opposite of that line, so it's negative 1 times 1. So my slope of the line that is perpendicular is 1. All right, number 12, okay? Use your angle addition postulate here. F, okay, VW is 22. U, VW is 27x plus 8. U, VF is 24x plus 1. Okay, let me make sure I did that right. F VW is 22. Okay, so we got that. Okay, and then U VF is 27x plus 8. Sorry about that, I mixed that up. Then the whole thing, okay, is 27x plus 8. All right, and so I'm going to set that up, solve for x. All right. Okay, now we have reflections, okay? Reflecting across where x is 1. So where x is 1 is right here. Okay, so when you have points that are directly on that line, they're going to stay on that line when there's a reflection. So where x is 1 right here, v and x don't move. The only one that's going to move is w. The y values stay the same, but they move equidistant from the line of reflection. So if I go W to here, that's 1. So I'm going to go over 1 more, and that's going to be right there. So my new image, or my image, is going to be, or y, or W prime is going to be x is 2, y is 3. Okay, and the other point I have to move is u. Okay, so I'm going to go back to. So now I'm going to go back 2 more. Okay, and so I'll have where y value is still 0, and my x value, okay, is negative 1. All right. Then, translation, all you're doing is moving this based on this. So your x values are going to increase by 4, y values are going to increase by 6. Most of y'all know how to do that. Okay, rotate 180 degrees. Okay, so if I rotate 180, okay, around the origin, okay, this just means that all of my x values and y values, okay, they're going to now be negative. Okay, so where I have x is 3 and y is 3, now I'm going to have where x is negative 3 and y is negative 3. So E prime is going to be right there. All right, and then same thing with all of these points. All right, now they want us to rotate 90 degrees clockwise about the origin. So we're going to go this way. Okay, we're going to go this way. And if we're going clockwise, that's the same as 270 counterclockwise. Okay, and when we do 270 counterclockwise, again, all of your X and Y values automatically flip. So you know that you got to change all of those except your X values, okay, are now the X values that are now the new Y values. Those are now, the signs are changed. All right, and again, I'll still have the sign up in the room and everything. All right, so that is review from what we've done so far up to this point this year. And now we're getting into your favorite stuff here, okay? Aha, there they are, proofs, yes. Now, there are 6 proofs on here. One of these 6 will be on the test. I haven't decided which one yet, but one of these 6 will be on the test. All right, and then the rest of the test questions will come from the homework. Okay, so look over your homework. Okay, there's a benefit to doing it. There's a reason why I wanted you to do it. There's also a reason why I just didn't want you to copy down, which I know some of you did. Okay, and it's going to show when you come to the test. All right, so I have my first part here where PQR is a right angle. Sorry about that. I have PQR as a right angle. Okay, that's given. All right. Then I have PQR as 90 degrees. Now, what makes the definition of a right angle is when it's one angle. Okay, when it's complementary angles, there's going to be 2 angles. All right, and then when we talk about, we are going to need to talk about, oh gracious, I think they're called complement congruence and supplement congruence. We're going to go over those. We're still going to have the same reason because it's still a transitive proof. It's just when I was looking at some other material, I did see this, and so I thought, okay, we better know how to say it this way. So, definition of a right angle. Now, when you have it written out just like this, just like what's up here, PQS, SQR equals PQR. Okay, that's angle addition postulate. So now, okay, I'm taking this same thing, but now I'm making 90 degrees. So we start up here with 90, we come down here, okay, to PQR, and then we go here to 4, okay, and so that's transitive. And then these are complementary, definition of complementary angles. All right, next one. All right, so, oops, went a little too far. Let me try to get the whole line. Oh, I didn't get the whole line in. My apologies. All right. Okay, so we know that X is sitting way up here. All right. So YW, okay, YW and YZ, okay, are congruent. All right, so that's what they tell us. And then XY is congruent to VY. All right, and that's given. Okay, so now, all right, I'm going straight from here to here. All right. All right, and so I have, if I'm going from congruence to equal, I know that's definition of congruence. Okay, now, just like with angle addition, you now have segment addition, okay? The reason why they teach these two at the same time is because there's so many similarities. Okay, when I take XY, which again, X is sitting way up here, plus Y, in YZ, I get XZ. So that's the example of the whole thing, all right? So that's going to be angle addition postulate. Now, I'm saying that since some of these are congruent to each other, XY is equal to VY, YZ is equal to YW, okay? So I just substituted this in. You don't have to put this on the test. And again, when I do the test, you're going to have all of these, okay, given to you. All right, in a drop-down box, you'll have 7 choices, and you have to put them in the right spot. All right, then the next one, okay, again, you have given, multiply both sides by 2, multiplication, segment addition, substituted in, and subtraction. All right, then we have angle postulates, and that will be on the next video.